So, hello and welcome to Castálio Podcast, episode 119. I am Bruno Rocha, speaking from Guarulhos, São Paulo.
I am Eliezer Rezende, speaking from Pouso Alegre, Minas Gerais.
Today, as you can see, we are recording another episode in English, and we are going to be talking about one of the new programming languages that has attracted attention from programmers and companies around the world. Presented by Mozilla as a safe, practical, and concurrent solution, and with the promise to solve non-system programming problems. Rust language is also a multi-paradigm, a multi-purpose language, and we'll learn more about this language with one of its core developers and author of the Rust programming language book, so Carol Nichols. Welcome to Castálio Podcast, and please introduce yourself to our listeners.
Obrigada. I'm glad to be on the show. As you said, I'm on the core team. I'm also on the community team and the infrastructure team and the cargo team. Cargo is the package manager for Rust. I also maintain Crates.io, which is the package registry website. And as you also mentioned, I'm hard at work with my co-author, Steve Klabnik, on the Rust Programming Language official book, which should be coming out in print soon.
Great. So before we start, we will have some notes in here. So usually are three of us presenting the podcast, but today Augie cannot make it. So he left his questions in here, but he will not be attending and participating here live and also later on the audio.
Okay, I have another reminder, which is that if you want to win a ticket for the next Python Brazil conference, which will be in October in Belo Horizonte, Brazil, you just have to fill our form, which I'm going to share on the chat. And in the end of this episode, we are going to do a draw of one ticket. So I just pasted the link on the chat, and I hope you can get your ticket to Python Brazil. And that's it. So we can get started.
All right. So to get started, today we have two sides of the coin here. So I don't know much about Rust, and Bruno is studying it for a while now. And to get us started, Carol, please, can you tell us what is Rust? Why does it exist? And how does it compare with other system programming languages such as C++, D, and Go?
Sure. So Rust has come out of Mozilla research, and it is aiming to be a safer alternative to C and C++. Those languages are known for a lot of problems they have. It's very easy to mismanage memory in such a way that it can cause security problems and crashes. If you look at a lot of the security vulnerabilities that are in the news, the root cause of those often goes back to C. And there really hasn't been a language that has emerged as a replacement for C yet, but we're hoping that Rust is looking good, I think, which I wouldn't be working on it if I didn't think it had a chance. I think it's a really great alternative to C and C++ that have these safety problems. The reason Mozilla is interested in investing in it is because Firefox is mostly C++, and Firefox has had security problems and has been known to be slow. And another aspect that's difficult in C++ is taking advantage of multiple processors and writing concurrent code. Rust, because of the ownership system that we'll get into, it makes it a lot easier to write concurrent code that does the right things, and it prevents data races at compile time. So Mozilla is slowly adding pieces of Rust into Firefox, and I think a little bit in the MP4 headers has shipped already. A big chunk, so they've been working on an experimental browser called Servo, and they've been slowly pulling pieces of Servo over into Firefox as they're ready. A big chunk called Stylo, which is the CSS rendering component, is going to be shipping this fall in Firefox. It's available in Nightly now if you turn on a preference, and it's really fast and doesn't crash. So Mozilla has been very happy with what Rust has enabled them to do so far, and they're even working on moving Rust components into Firefox even faster than they had planned. I didn't talk about Go and D yet. So I actually haven't used Go and D myself very much, so I don't have any direct comparison experience, but a difference is that Rust does not have a garbage collector that runs at runtime. Go has one built in, and I think D, there's some history with D, like I think it's, I forget if it's on by default or off by default, but you can opt in or out of the garbage collector with D, but Rust just doesn't have one. And we'll get into this more with the ownership. So you do have to manage your memory explicitly, but it's not as tedious as in C, where you have to say malloc or free. But because all of this is happening at compile time, there doesn't need to be a garbage collector always cleaning at the memory at runtime. So this lets your program be a lot faster. And there are certain cases where you don't have the resources to have a garbage collector running, and Rust is a great option for that case.
Nice. So we can say that the key feature of Rust is the absence of garbage collector and the fact that it gives the programmer the full control of memory ownership. And then it prevents segmentation faults and race conditions. However, I think this brings a new level of complexity. And at the first look, Rust seems to have a weird syntax, especially because of this new concept of lifetime, borrowing, and also ownership. So when I started learning Rust 2 months ago by your book, I struggled a lot to get those concepts. And until now, I do not know how to easily explain lifetime, ownership, and borrowing to others, which ask me about Rust. So do you know an easy way to introduce these concepts? Do you have some kind of example to know for beginners to see what is ownership, borrowing, in lifetimes?
I don't have one magic example that will help everyone understand, unfortunately, or else I would have put it in the book, and then you would have understood it already. So I wish I had an example that was very small and very nice. So ownership and borrowing, in my mind, are much more important than lifetimes. Lifetimes, you can kind of forget about them for a little bit. So ownership, the concept is that one piece of code, one variable, one struct, one instance owns the memory that it's using, and that owner is what's responsible for cleaning the memory up when that thing is done. No one else is allowed to clean it up, and no one is allowed to assume that that data exists unless they know that the owner exists still. So borrowing is the owner can let other parts of code read, so you can do an immutable borrow, and you can have as many of those as you want at the same time in code. But none of those will, it's guaranteed that none of those will delete that data. So it's safe for everyone to read that data. Or you can let one part of code have a mutable borrow so that it's allowed to change the value for a certain amount of time, and then it returns the borrow. It stops borrowing, and then the owner is still responsible for cleaning it up. You can transfer ownership, so another part of code owns it, but then you're not allowed to use it anymore after you've transferred ownership. So what this does is, this is the part that lets you not have to write malloc and free every time you want to use memory, and inevitably forget to write free, or write free twice, or think this other code is going to free it, but actually it's over here that frees it. And so the part that's frustrating sometimes, I came from Ruby. So Ruby has a garbage collector, and you could just kind of, your data is all over the place. And you don't ever have to worry about cleaning it up, or who's responsible for what data. So thinking in terms of ownership was really different for a long time. But it lets, if you look at your memory usage of running Rust program, it's like teeny tiny, because it's like the data only hangs out as long as you need it to. And then it gets cleaned up right away. And you still don't have to write malloc and free. That is all just taken care of by Rust. The frustrating part is that if you write code the way you might write in Ruby, where everything's all over the place and accessible all the time, which uses a bunch of memory, sometimes the Rust compiler won't let you write that code. Your code won't compile at all, and you can't even test it or run it, which is really frustrating if you are used to working with code a certain way, and then it's like, no, you can't do that. And you're like, but I can write this in every other language I've used. So it's definitely different to think about this, but I never really understood C. All the like ampersands and stars and pointers, and it just never made any sense. And it was too easy to mess up, and you would just get this core dump. And it'd be like, you messed up somewhere, good luck. Whereas with Rust, while it doesn't compile, a lot of work has been put into the error messages to show you exactly where the problem is, and hopefully give you a link to give you more information about why that is happening. So I am able to write systems code in Rust, whereas I'm not able to write system code in C. So while it is difficult and complex and new and different, it's enabled me to write code that I couldn't before, and write faster code, and write code that uses much less memory. I feel like I just talked for a long time.
Yeah, nice. So I think that the fact that most people think syntax of Rust is word syntax is because of that ownership and borrowing reference and the referencing control. And do you think, I know this is a polemic, complex topic. I read some discussions on Reddit about this. But there are some plans to add some kind of syntax sugars or helpers to make the life easier sometimes for this, or Rust developers are very conservative about having the things written on this way. You just have to put this on your mind and work like this. Yeah.
Yeah, there are some possibilities to making the syntax clearer. And there are definitely places today that, so lifetimes are a way of telling a function how long the arguments and the return values live in relation to each other, so that the compiler can know that the code you wrote is valid, even though it doesn't have like the concrete values in there. That's the short version of lifetimes. And there are places where you have to annotate code with a lifetime parameter that there's only one way to write it. So the compiler should be able to figure that out, but we just haven't taught the compiler that it should be able to assume that yet. So the other aspect that affects changes to Rust is that we have very strong stability guarantees. We hit version 1.0 in May of 2015. And since then, we've promised that any code that you have written starting from 1.0 on will continue to compile in newer versions of Rust. So any changes that will break old code are not allowed. So the entire syntax is not likely to change, but we can tweak parts of it to make it more ergonomic. There's a big initiative going on right now called the Ergonomics Initiative, which is trying to improve these paper cut parts where we could make the compiler understand things so that you don't have to write this weird syntax. So there's work going on in this area, but it's difficult.
Nice.
Okay, so before we move on to the next question, we had some comments here on the chat. The first one is from the profile called Rustlang BR, and I think it's Mario Edival who is speaking. And while we talked about D and the garbage collector, he's saying that it's not on. I mean, it is on by default, but it's not easy to turn off because there are some things that depends on it. And the other comment we got here is about a operating system with a microkernel, which is called Redux. I think that's the right way to say that. So I wanted to mention that because, as I said, all about Rust is new to me, and I really found out very interesting, because especially the operating system one, because you said that maybe in the future Rust will be able to replace C. So yeah, it seems to be the case with the operating system and the library. I see that they have a kind of libc, which helps you do stuff.
Yeah,
right.
Go ahead.
I'm sorry, you can go.
I was just going to mention there are some like Linux command line utilities that people are rewriting in Rust. The most exciting one is called ripgrep, and it's a re-implementation of grep, but it's way faster. So that sort of thing, it's going to take a long time to get an entire operating system of the scale that Linux is. But there are little pieces that are already happening, which is very exciting.
Indeed. So moving on, another Rust component that has been highly prized is the package and dependency manager called Cargo. So Cargo has even been copied to other platforms and has even inspired NPM, which also has some parts of its own code base powered by Rust. So you are one of the developers and maintainers of the Crates.io, as you've mentioned, website, which is the Rust's official package repository. Could you please tell us more about Cargo and Rust packages, and then what are the challenges of maintaining the main Crates repository? Sure.
So the interesting thing about Cargo and having a package manager is that like C and C++ don't have anything like this. So being able to use tools that developers are used to from Ruby and NPM and JavaScript is kind of a new exciting thing for systems programmers. Rust in the time up to hitting 1.0, because of the stability guarantees, a lot of the functionality that wasn't quite ready to be stabilized was pulled out of the standard library. So for example, random number generation is not part of the standard library, which is a little different than most other languages. And this functionality was moved into what we call a crate, which is the name for a library. And because Cargo makes it so easy to use crates, and Crates.io hosts a whole bunch of crates that people have written. I won't say it doesn't matter that they're not in the standard library, but it matters less than having something in the C++ standard library, for example. We're trying to make it very easy to make small libraries that are easy to install and use in order so that each library can iterate independently and nothing gets stuck in the standard library, maintained forever. Since we didn't have as much time to spend on things like random number generation as we did as the core functionality leading up to 1.0. So it's been really fun working on Crates.io. We are at a much smaller scale than NPM or Ruby Gems. I have a friend, Ashley Williams, who works at NPM, and I'm very grateful to her help because they've hit a lot of problems with scaling and spam and things along those lines that we're too small to have yet, but I am glad I know they're coming so we can prepare. I think a challenge is that we're still working through is trying to make it easy for people to find libraries that will do what they need them to do. We're working on adding badges and different information, trying to make it clearer who wrote a crate. We recently added, we're now rendering the README of a crate on Crates.io to try and help show an example of how you would use the crate. But ultimately, you're never going to replace trying out a crate to see if it does what you need it to do for your use case, and that's a hard problem to try, and that's what everyone would like us to be able to tell them automatically. But so it's been interesting and difficult trying to figure out how to replicate that, or not replicate, but provide more information than just the name of the crate. So.
Right, so to give us an idea about the stats, do you know how many packages are currently available on Crates.io?
I know it's over 10,000. I'm pulling it up right now. 11,348 crates are available today.
Oh, that's a huge amount.
Let me look up NPMs real quick.
Yeah, I know that Python has, I think,
150, something like that, I think.
Yeah, 150,000. Yeah.
Yeah, so that's a lot more. NPM has 475,000. So I'm not good at doing math in my head, but that's a lot more on NPM than we have on Crates.io.
But I think it's a good number because NPM is out there for many years more than crates. All right, so to know a little bit more about the diversity of the Rust package ecosystem, we also got a question here from the chat. I think it was Alejandro Messias. He asked about web frameworks, and maybe you could comment about how, do Rust have data science libraries? Do Rust have web frameworks? I don't know how many types of different packages or ecosystems would be available on as Rust crates. It's not packages, it's crates, right?
Packages, crates, yeah, either works.
Cool.
The web frameworks is really interesting. There isn't there's not a Rails for Rust yet. There are some pieces and there are some smaller frameworks. Iron and Nickel are two of them that are, Nickel has been based on Express.js, and I think Iron feels a little bit like Sinatra from Ruby. So they're kind of simpler web frameworks. There's a few newer ones that have come out. Rocket is one that makes a lot of use of Rust macros, which let you do kind of templating sort of like things. So some people like that and some people don't like that. It also uses Rust nightly for some extra features that have not been stabilized yet. So, and again, some people are happy to use nightly and some people would prefer to use the stable channel. A new one that just came out recently that I haven't had a chance to try yet is Gotham. And so that there's new web frameworks all the time, and the community there's not a clear winner yet. Another interesting piece of the web framework is the ORM, and so this would be a library that will talk to your databases and create Rust data structures that correspond to your databases. And in that space, Diesel, which has been written by Sean Griffin, who has worked on Active Record for Rails, Diesel is probably the clear winner at this point. It's getting more and more fully featured all the time. Crates.io uses Diesel now. And so that is a piece of the web framework story. And I think we're going to continue to see more experimentation around pieces of the web framework and trying to put the different pieces together so that there are definitely people working on making a web framework that will make it easier to make web applications in Rust, but we're still kind of figuring out the pieces.
Nice. I also want to mention another crate I like very much, which is CERD for data serialization. It's very interesting that it can transform JSON data into Rust structs, and it's very magic somewhat. It just works. I like it very much. And I think this is one of the Rust crates we can copy and make it a clone on Python, Ruby, and other ecosystems, because it works very, very nice. Yeah. And so just to complete the previous question, do you know if there is some place for data science in Rust yet or not? There's some experiments or?
I know there I'm not very familiar with this space. I know there have been some machine learning type things. I think, again, like there are people who want to get there, and I think there's work to do to get like the scientific and math algorithm libraries built up before it will be easier to write a data science machine learning kind of thing. So I think that's coming.
Yeah. I have one more comment about this topic, which also I think it's polemic. In Python community, it's very polemic topic. We already discussed this on our on some episode, which is about documentation. And there is a feature I like very much in Rust, is the fact that documentation can be written in the code using Markdown syntax. And Python developed its own language, which is Ruststructs test. Most of people on Python developers like, but I feel more comfortable with Markdown, and I like it. But I know that Markdown has some limitations sometimes, and I just want to know, what do you think about it? It's working good, or the limitations of Markdown are already hitting Rust documentation space?
I think most people are happy with Markdown. I'm trying to think of any limitations, and I can't think of anything off the top of my head. My favorite part of the Rust documentation that goes with your code is that you can put examples in in your Markdown that get shown on your documentation. And then when you run your tests, that checks to make sure your examples compile too. So that's a really neat way to keep your documentation examples up to date with your code. So that has worked out really well. And we actually use that with the code examples in the book so that we can, but the code examples don't always do exactly what we want it to do, especially as Rust upgrades and sometimes fixes problems, and then we expected something to fail, and then it starts passing. But that lets us find those problems a lot easier and make sure that we at least keep the examples compiling that we mean to be compiling. So that's been very useful.
Nice. Yeah, I know that Python, which is I talk about a lot about Python because it's the language we most work. And Python has this feature which is called doc tests. I think it's there from the beginning of Python, and I think it's really interesting. I use this a lot, but the community just is not using this anymore. I don't see people using this on Python. People prefer to write the tests separated on other frameworks. But I think it's a very nice feature. And while learning Rust, I usually go to the source code of the crates and I read the comments there and I just see the examples. And I think it's very easy to get it. So. Okay, now I want to change the subject a little bit. We are talking a lot about the advantages of Rust and how Rust is wonderful and maybe the future of systems programming. But let's talk about its disadvantages. I don't know if there is a lot because I do not have had too much experience, but I have 3 disadvantages to mention. And I would like to ask you a small sentence about it. So the first one I already started talking, which is the lack of resources targeting beginners. In other words, I do not see too much Rust for Dummies tutorials and things like this. So it's not easy to get started learning Rust. So what do you think about it? And is there some kind of working group doing some work for this?
So there is a documentation team, and they have a wide variety of focuses, including documenting crates and documenting the standard library, as well as creating things like tutorials. I definitely think we need more resources. Our book should be coming out in print soon. There's a book from O'Reilly that I think is, I forget if it's been released or not, but it's very soon. Manning is coming out with a Rust book as well. I think we need lots of different resources for lots of different people from different backgrounds. A challenge with the Rust book is we're aiming for, our target audience is people who have programmed in at least one other language before, but we're trying to make it relevant for any programming language. So it's sometimes difficult to give people coming from C++ and people coming from Python, Ruby, JavaScript the types of resources they need in one book. So I want more books and more tutorials and different kinds of things. One of my own projects a little bit, I have this project called Rustlings, so little bits of Rust, and it's a bunch of examples that intentionally don't compile, and your job is to try and fix them. And I haven't had much time to spend on it lately, and there aren't all that many, but people have found them useful, and I think that's a good way for people who like to get hands-on experience with things. I started it because I was getting all these compiler error messages while I was trying to do something else, which was very frustrating. So I wanted to just practice fixing those compiler error messages so that when I found them while I was doing something else, I would already know how to fix them. So I would love if people have ideas for more exercises as you're learning. And another thing that's difficult when learning anything is that once you understand something, it's hard to remember what it was like to not understand it. So I almost know too much at this point. Like we need more people writing more things like right after they learn something. That's the best time to teach someone else. So anyone listening who tries out something with Rust and figures something out, please blog about it. Please write a tutorial and share what you figured out, because we need more stuff like that.
Great. Yeah, your project Rustlings is on my to-do list. I already
Awesome.
started the exercise.io, and when I finish this, I will start looking to the Rustlings. So I will just talk about the other thing I think people say that is a Rust disadvantage, especially people coming from C and C++. They found that when your project has a lot of the dependencies and you go to compile, the compiler takes a long time to compile because the way it compiles crates separately, at least for the first time. And also that the size of the generated binary is a bit more larger than one generated in C or other language. What is this about? Is that the way Rust works? Or is this something developers are working on to improve?
This is definitely what I would put as Rust's biggest problem. And there are definitely people working really hard on improving compile times. There are a bunch of different efforts. One is incremental compilation. There's a way you can try that out now. It's kind of in beta, but they got it to a certain point and then realized a different way they could do things to make things even faster. So it's kind of being redesigned and reworked at the moment, but they're trying to get that finished around the end of the year. There's also the size of the binaries. I'm going to look up an FAQ because I'm not sure off the top of my head like what there are definitely reasons why this happens. Yeah, so the type system of Rust is complex, more complex than C, definitely. And it's doing a lot of checks at compile time on various different things.
Yeah, I think I heard I read somewhere that when you compile without there are some parameter, which is, I don't know if it's optimized or something like this, you get all the messages to trace back if you have some error on compile time. So you can remove that out and have a small binary or something like this. I don't know if it's the same stuff you were talking about, but I read about it, yeah.
Yeah, there are definitely different options. And by default, when you run cargo build to build a project, that runs in what's called debug or development mode. So that has a lot of symbols and extra backtrace information and things like that. And it also doesn't spend as much time on doing passes of optimization because the assumption is you're currently working on it and you'd rather, believe it or not, the release builds take longer to run. So the default is to take a shorter amount of time. But when you're done and want to release a compiled version, you can run cargo build -- release, and that will take a little bit longer, but will produce smaller code that has more optimizations run on it. So that is one option that you have. And there are some other little tweaks you can do. You can also run without the standard library if you really want. That's what if you want to use Rust in an embedded context where things need to be really tiny, you can run without the standard library. So that's another option as well.
Great. So I will change gears a little bit here, and I want to talk about the Rust market share. So we also got a comment here. So I told in the beginning that Og Maciel wasn't participating, but he sent a comment, and that's not for the first part of the question, which is how is the market share in terms of companies currently using Rust, and what type of job or of type of problems they are trying to solve. And the second part, and that's come from the chat, which is how is the market share for a Rust developer? So someone who got interested on learning Rust and thinks that is ready for trying to find a position. So the first part is what is for a company using Rust, what they are doing. And the second part, I know Rust, what types of job I should find and what is the knowledge I should have in order to be able to try to get a position.
Sure. So if you go to the Rust.lang.org homepage, there's a link on there that says see who's using Rust, and this links to a page of everyone who is able to say publicly that they're using Rust in production. So Mozilla is on there, of course. Another, I actually don't see Dropbox. No, there's Dropbox. Dropbox is shipping Rust in their client software. Habitat by Chef is a DevOps tool that uses Rust. As we mentioned, NPM is using Rust for some of their infrastructure that needs to scale. And there's a whole lot of little startups that are betting on Rust for their products. One of them is Tilda, which does Skylight, a product that does performance monitoring for Rails apps. So it runs inside people's Rails apps and needs to not use a whole lot of resources and needs to not crash other people's applications. And Rust was pretty much the only and for something maintainable and safe that a lot of people could work on. So there are a bunch of startups like that who are using Rust. There are also projects at some bigger companies that aren't listed on this page for bureaucratic reasons. Amazon is testing out some things with Rust. Facebook is using Rust. They have made a Mercurial server that can handle their humongous mono repo written in Rust. I think Google is using Rust for what is it? Fuchsia, I think, is their experimental operating system or something like that. I'm not sure exactly the details on it. And Microsoft is actually shipping a bit of Rust in VS Code. The code search uses ripgrep, the grep rewrite I was mentioning before. So the big companies are all starting to experiment with Rust a little bit in different places. And Mozilla, of course, is all in with Rust and moving forward. The job market is not as big as other languages right now. And a lot of places like Dropbox, for example, are not necessarily hiring full-time Rust developers, but people who can work on other things and Rust as well. And I think that's a situation that a lot of companies are in, where they have a little bit of Rust, but they also have something else. So if you're looking for a full-time Rust position, those are there aren't very many of those right now. But if you're open to working in other things, or are I would not recommend trying to use Rust at a company that it wasn't a good fit for. But if you have a use case for Rust, I of course am biased and would recommend using Rust wherever possible, wherever you're thinking about writing new C or C++ code. I hope people stop doing that.
Nice. Yeah, I also see some companies which were using Rust to distribute command line applications, as they can just ship the binary in a single binary with all the link static libraries inside. So that's very good use case. And now I want to move on to another topic, which is we know that Go language is one of the most popular languages of the new languages, and it has been advertised by Google and others as a good choice for concurrence and async programming. And we know that Rust can do the same thing very well. And also Go is also sometimes adopted as a Node.js replacement. And also Go language has a very large use case, a very big use case, which is Docker, a famous use case. So do you consider Go and Rust direct competitors? And what is missing to Rust to hit the same popularity and adoption as Go?
So I don't really see them as direct competitors. I think that's kind of a coincidence about when they came out. And Go was advertising itself as a systems programming language. And I think they're kind of backing away from that a little bit. They're really aiming for the asynchronous network programming is kind of the sweet spot for Go. And there are efforts in Rust to do asynchronous network programming. Tokyo is the big project that's under development right now to do that sort of thing. And we're working on adding coroutine support to the standard library. That's kind of in an experimental phase at this point. But again, like I think Go obviously has Google behind it, so that Google is very large, and that makes it that gives them some credentials that Go is probably going to stick around. And you know, if Google picks it, well, then it must be a good decision, sort of things. And we don't really have that yet. We haven't really proven ourselves. I think Mozilla using it in Firefox is going to be a big deal as that becomes more and more using Rust, and it goes out into the stable Firefox, and people are able to experience how much faster it is. But in general, I think we just need more evidence and more people using it in production, and more time to show that we're stable, it's going to stick around, it's safe to depend on, and that sort of thing. So I think it's just going to take time.
All right. So getting into the subject of people willing to learn more about Rust. So how they can get involved with Rust. We've mentioned about your book and some of the tutorials out there, also the Rustlings project you have. So what else is available to someone trying to learn Rust? Like maybe YouTube channels, books, groups. Also, if you can recommend or suggest any code editor or something that would help writing Rust, that will be great.
Sure. A lot of people like using VS Code, Visual Studio Code, for Rust, and that's one of the projects is the Rust language server, which is trying to provide a common backend for a bunch of different editors for things like code completion and jump to definition and things like that. And the VS Code extension is one of the first uses of that in a real editor. So I know people who use that a lot and really enjoy the experience in VS Code. As far as the other books, there's also a video series called Into Rust, and I think it's intorust.com. And there are people working on adding more videos to that, but that's a bunch of screencasts. Let me think, what else? So there's an interesting effort going on right now that we're calling the impl period, the implementation period. So from now till the end of the year, we usually make decisions through this RFC process, request for comments. But it takes a lot of time to write up a proposal and discuss it with a whole bunch of people and refine it and decide on it. And there's actually a bunch of things that we've decided we want to do, but that we haven't had time to implement yet. So from around now until the end of the year, we're not going to be focusing on working on requests for comments and proposing new changes to Rust. We're going to work on implementing the things we've already decided we want to do. And there's about 35 working groups of people leading these little teams who have made a whole bunch of starter issues for people to start contributing to Rust. So there's details about this on the Rust blog, blog.rust-lang.org. It should be the latest post on there. So, and there's a Gitter chat room for every working group, and there's lists of starter issues for you to get started on. So if you've gotten started and you want to contribute or want to get going on a real project, this is a great time to get involved and a great way to get help doing that. There's also a Rust beginners channel on Mozilla IRC that is full of really friendly people who will answer any question that you have about Rust.
Cool. So the chat here is on fire. We got another question here. Is there any Rust testing framework? It is built-in, or you need to install it?
There's basic built-in testing functionality. It's you can write a test function and you have things like assert and assert equal. And that's enough to get going with testing. This is another area that I'm interested to see how things come out. And there was a library I haven't tried out, but I wanted to try out that I saw that like makes better error messages when your test fails. And it makes like a colorful diff. It's called Pretty Assertions. So when you have like a whole bunch of stuff that doesn't match, it tries to highlight the small parts in there that don't match. So again, we're still kind of in early days and the functionality is basic, but there's opportunities for libraries to improve this.
Great. Yeah. So, and as you were talking about the implementation period, which is starting right now, what about the future of Rust, and what is some interesting new things you developers are working on and we can expect on the next releases? There are some really breaking change or breaking feature?
The breaking change is interesting. One of the RFCs that got approved recently was one to introduce the idea of epochs into Rust, to make Rust kind of like C++ and Java, where you have like C++ 11 or C++ 17 and make small backwards incompatible changes to improve the language. So we haven't made any of these changes yet, and we just approved a framework for possibly making these changes. And the scope of these changes would be very small, and I think the plan is to make an automatic tool to upgrade your code to the new version automatically. And by default, if you don't, you have to opt into the new epoch. If by default, if you don't do that, all your code will just continue to compile, and you can keep upgrading the version of the compiler, but stay on the old epoch. So this was a very controversial change. I think where we ended up is good because it will allow us to make some improvements to the language without breaking old code. But again, we haven't made any of these changes yet. So exactly how this will work in practice is yet to be determined. But that is something that will change things in the future, definitely. Yeah, if you would like me to share my screen, I can go through Hello World.
Yeah, just for those who are watching us on YouTube, you can see, I think maybe there are people here which never saw a Rust code before, and we were talking about a lot syntax, and so if you can show us some small example, a simple hello world.
Sure, I'm just getting set up here. And let me find the share screen button.
Yeah, it's the green one with an arrow.
All right.
On the left panel, yeah.
Here we go.
Yeah, nice.
Okay. So this is the Rust playground. This lets you run, it's not actually running Rust in the browser yet. What it does is you can type in Rust code, and it will hit, when you click the run button, it sends it off to a server, which compiles it and then puts the output here. So this is Hello World in Rust. We've got a main function that takes no arguments. And we start the function body with curly braces, so that should look pretty familiar. Printing is done with a macro called printline, and you can tell it's a macro because of this exclamation mark here. And then you can say whatever you want. So I'm trying to decide what to show next. I kind of want to show like an error message or ownership and borrowing. Let's show, so what I've done here is I'm declaring a new variable. So we're saying let x equal to 3. And so 3 is a number and it's an integer. So let's try adding an integer and a floating point number together and see what happens.
Interesting to mention that you do not have to declare the type of X. It has a type inference.
Yes.
For some type, yeah.
So Rust is statically typed. This definitely has a type, but most of the time, Rust can figure out what you want based on how you're using it. So there are times in function signatures, for example, you do have to say exactly what the type is that you are of each argument that you take and of each of the return type. So by making you annotate the types here, that lets Rust figure out the types in a lot of other places. So you can see here we've tried to add a floating point number and an integer, and this is not allowed. Adding is what's called a trait. So floating point numbers do not implement the trait for adding to an integer. And it has pointed out exactly where our problem is. and said, no, you can't do that. Another error that I kind of, so this function I've written here says it returns something, and it actually is not returning anything. This error message is not super great because this is the like empty type. Another interesting thing is that Rust doesn't have null pointers. So if you, in Ruby, this would come up as undefined method on nil is like an error that I would get all the time. In JavaScript, this is kind of undefined is not a function types of errors. When you think you have something and you actually have nothing, and the error that you get is really far away from where you made the assumption that you had something or nothing. So Rust, you can always, when you say that you have something, you can trust that you always have something. And that has been, now when I don't have that, I miss that. So for example, if we were to actually add one here and return that, I don't have to add any nil checks in here. I don't have to make sure that X is not nil because I've said the type is an integer that takes up 32 bits, and Rust is going to make sure that that's what that type is, or it's not going to compile this code if I try it and pass something else in. So that's another part that I really like.
Yeah, your example has another nice thing, which is a common pitfall for who are starting learning Rust, is that you do not have to use the return keyword. You just put the last expression on the function, and it just be the return value. That's a nice thing. I like it. But sometimes it's confusing because if you put a semicolon there, it's completely different.
Yeah. This error message has definitely gotten some work because this is definitely, I do this a lot. So because this is an expression and a semicolon makes it a statement, and then statements don't return their values. So if you put a semicolon at the end of the last line in a function where you're trying to return it, it doesn't actually return anything. It returns this empty tuple type. But this help message is actually really helpful. It's like, consider removing the semicolon, and that is indeed the problem. But this is a really common problem.
Yeah, nice. I like it, but it takes some time to get used to return the last line of your functions. But it comes to be very readable with time. Yeah, very nice. I think our people who are watching us on YouTube now has a simple idea on how is Rust syntax. It's not very weird, but you just need to be used with this small things like return and semicolons, but it's very nice. Okay, so before we go to the last part of our show, which is the interesting top 5, I will do a quick break because we are today giving a ticket for Python Brazil conference. And now I just want to know who is the winner. So my time to share my screen. 1 minute. And now you guys are seeing my screen. And we had for this episode 11 people who filled our form. And then we are going to find who is the winner. Interesting thing is those people are from Belo Horizonte, which is the city where Python Brazil is going to be. So I think you are not going to spend with travel and hotel. That's nice. So let's see. I'm going to get one number between 2 and which is the last one, 12. And Our winner is number 9, which is Antonio. And Antonio, I'm going to send you an email and the instructions for you to get your ticket to Python Brazil. And on our next episode, we are going to give another 2 tickets for Ruby Conference, which is the biggest Ruby conference in Brazil. So next week, we are going to give them another 2. And that's it. Let me stop sharing my screen. And now it's the time for the final top 5, the most interesting part of our podcast.
All right. So it's been a great conversation, but we from Castálio, we don't care only about technology. We love technology, but we also want to learn a little bit more about the person we are interviewing. And that's why we have this top 5 section. So we would like to know which are your suggestions for music. So it could be when you are writing Rust code or just chilling or something else. So let us know, what would you recommend for us to listen?
Okay, I'm going to pick my favorite band, and don't laugh. My favorite band is Hanson. And if you haven't thought of them since Mbop came out about 25 years ago, they're still around and they're still writing music and releasing new songs. And they just released a song called I Was Born, and I think it's really catchy. So I would encourage everyone, even if you think you might not like it because you didn't like Mbop 25 years ago, give it a chance and see what you think, because I think they're still really good and still writing awesome music.
Very nice. I didn't know that they recorded new music. I think that band ended some years ago.
Nope, they're still around.
Yeah, we have a playlist on Spotify, so we are going to add your recommendation for Hanson.
Awesome.
Yeah. Okay. So I think now we are going to ask you about books. Do you have any book? Don't need to be technical. Any kind of book. Anything you like to read?
I have 2 book recommendations. One is a book of short stories by Roxane Gay called Difficult Women. These are hilarious and sad and interesting short stories about a lot of different kind of women. So I'm in Pittsburgh, Pennsylvania, and she recently came and did a lecture, and I was lucky enough to go and hear her, and she's hilarious in person. So I love her short stories and would recommend Difficult Women. The other book I have recently finished is called Station 11, and it's by Emily St. John Mandel. This is a post-apocalyptic novel about a world where there's been this flu that has killed most of the people. So there's just these small communities still left, and it's a really neat story about a lot of different people and how their lives entangle together, and what their lives were like before and after this flu. And it was a really good story.
Excellent. So the last thing we want to know is about movies, and it could be not only movies, but also TV series, whatever related to TV in general.
This is a hard one that I don't have one picked out. The TV I'm watching right now is the newest season of BoJack Horseman on Netflix. It's a very dark comedy, but it is very funny, and I really enjoy that. Like, half the characters are animals for no good reason, and they still have like normal lives, and they make fun of our lives right now, and I think it's funny.
Yeah, very nice. I like that show. BoJack Horseman is very, very funny. Very a lot of black humor there.
Yeah, yeah.
They are very dark side of humanity, but
Yeah.
it's very nice to watch it. I also recommend it, and we have this on Netflix Brazil also, so I recommend. So sadly, we hit the end of this episode, and first I would like to thank you, Carol, not only for being today with us for 1 hour and sharing your knowledge, but also thank you for all your work on Rust, your book, which introduced me to Rust, and also your work on crates and everything else. I think you do a great job, and all the Rustaceans out there are very grateful for your job. So thank you. And I would like to give you some time to say whatever you want, do some advertisement, say a final message for our listeners. So the time is yours. Say whatever you want.
Sure. So I think we've plugged the book enough. I do want to mention that it's online for free right now. It's still being developed, so the later chapters are still a little rough around the edges. But please read the book and send in comments. Again, it'll be out in print form from No Starch Press soon. I also run my own company with my husband, Jake. It is called Integer 32, and we do Rust consulting. If you are trying to convince your company to use Rust and would like some help, we do training and we build prototypes and things like that. And I would encourage everyone to try out Rust and write tutorials. As we mentioned, we really need lots of tutorials from lots of different perspectives in order to help more people pick up Rust, because I think it's a really neat way I think it's making programming better. So I want to help Rust become more widely used than C. So we've got a lot of work to do, and we need your help.
Great. So it is the end of this episode. And before we go, I want to thank everyone that has followed us live here on YouTube, everyone that will be listening to us on when the podcast goes out. Also, we'd like to ask you to follow us on our socials. We have a Facebook page, we have a Twitter. Also, our website is castálio.info. Feel free to drop us out a comment and suggest anyone else that we want us to interview. Was a great time, Carol. Thank you very much. And I'd like to say bye-bye to everyone and see you all next week.
Bye.
Bye. Thank you.